Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. This is part 2 of transformations of functions. So if you haven't already seen part 1, I'm going to link that video in the description box below. Please go ahead and take a look at it. Let's start. In part 1, we saw the translation of the parent quadratic function given by this equation y equals x minus h the whole square plus k. That h gave us the idea of the horizontal translation, okay, h being positive, horizontal to the right, h being negative, horizontal shift to the left, and then k being positive, vertical translation upwards, k being negative, vertical translation downwards. And we saw a very similar idea even for the parent absolute value function, where this equation absolute value of x minus h plus k again gave a very similar idea, h affecting the horizontal translation and k affecting the vertical translation. And you know what? The same thing can be generalized for any function, meaning you can write y is equal to f of x minus h plus k, and this equation can be used for any function. F can be a square root function, f can be a trigonometric function, f can be an exponential function or a log function. You can still have the translation of any of those functions being described by an equation something like this: f of x minus h plus k. X minus h is inside the bracket. That means it's affecting the domain. This is inside, affects the x values or the domain, okay? Whereas k is outside the bracket, outside of f, but that's the new y. So it's f and k. So this term affects the range. Is this clear in the visible for everyone? Okay, so x minus h is inside the bracket. It's going to affect the domain of the functions. K is outside of the bracket, that bracket meaning f of x, okay, that bracket. It's going to affect the range of the function. So the range are the y values, so k affects the vertical translation. And x minus h being the domain affecting the x values, that's why it's affecting the horizontal translation. So this is somewhat like a translation equation for any function. However, there's a difference. In the case of the quadratic and the absolute value function, we saw and we noted that hk, the coordinates h comma k, were the coordinates of the translated vertex. Okay, when the absolute value function was translated, hk gave us the coordinates of the new vertex. Same thing was for that quadratic, that hk gave us the coordinates of the new vertex. But for any function, that can't be generalized. Yes, you can generalize the idea of the horizontal and the vertical translation, but the coordinates h comma k would mean something else, something different for different functions, not always going to be the vertex, okay? So let's take some examples, all right? Let's say our function, this is example 1, our function was the square root function, okay? In that case, if we were to rewrite this general translation equation, we're talking about translations, right? The general translation for the square root function would be y is equal to f of x minus h, right? So instead of f, you're going to write square root of x minus h plus a k. All right, f is square root this time, okay, the square root. So we've written square root of x minus h plus k. This is going to affect the domain, horizontal translation. This is going to affect the range, vertical translation, okay? Now, let's take, for instance, h and k to be 2, 3, all right? That means this equation would then be y equals under root of x minus 2 plus 3. Okay, literally we are seeing a shift to the right by 2 units and 3 units up. But what would these coordinates 2, 3 denote or represent on the graph of the translated square root function? Let's find out, okay? So on the calculator, let's add a graph page. And first we are going to go and add square root of x as to represent the parent function. So you go, there's the parent function. And what I'm going to do is that I'm just going to go and denote the coordinates of this point, all right? Let's just use the trace option, and there we go. That when I hit enter, those coordinates are represented there. Okay, that's 0, 0. That's the coordinates of that starting point, if you want to call it. You can't call it the vertex, of course. So I'm going to hit escape. Okay, so that's 0, 0. And now I'll enter the translated square root function, which was x minus 2 under the square root, and outside the square root we had a plus 3. So h was 2 and k was 3, and hit enter, and I get that graph there. We're interested in comparing these points, whatever you call it. It's not the minimum value. Well, it's sort of the minimum value, but it's not the vertex, okay? So let's go and use graph trace, and we are on the blue graph. So let's just come here, and I'll just jump to the other graph, and when I come back, it's undefined because of the step size. So let me just go and change the trace step. And I don't want it automatic, but I wanted something like 0.1, and I'll say okay. And now I can back up, and there you go. The red graph, as you can see, at x equals 2, the value is 3. The x equals 2, that's value is 3. And that can be compared, okay? 2, 3 represents that value. So if I hit enter, all right, so that's registered there. Can you see that? Now you compare, okay, 2, 3 represents this point, okay? That's also the minimum value of the domain, okay? H represents the minimum value of the domain. Remember this H and K? H represents the minimum value of the domain, and 3 represents the minimum value of the range of this function. The same way as 0 represents the minimum value of the domain of the parent function, and 0 again represents the minimum value of the range of the parent square root function. Let's try it with another translated square root function, okay? This time, let's try and shift it to the left side or somewhere below, all right? So if I'm just going to go and enter, let's say x plus 5, and outside the square root sign, let's just make it minus 7, which means it's going to go the parent function, okay? The parent function is going to go 5 steps to the left and 7 steps below. Hit enter, and there's our graph, okay? And here we go. You can see all 3 of them now. Let me just move this label out here. That's in black, okay? Now let's observe this point, okay? That's H and that's K. H is -5 and K is -7, all right? Let's just watch that point, okay? So again, we use trace, and we want to come to the black graph. So I'm just going to jump from there to the blue graph and then to the black graph, use the trace, come down, and watch this, okay? Watch this on the bottom right hand corner. And as I keep coming down, and there you go. Can you see the coordinates of that point? I'm going to just hit enter, and now I can hit escape to get out of that tool. There you see H is -5 and K is -7. So as you can see, H comma K, whether it's a parent square root function or whether it's the translated square root function, H comma K gives us information about the domain and the range, the minimum value of the domain and the range. So let's make a note of it. So in the case of a square root function, the domain, the translated square root function, the domain is H comma infinity, and the range would be K comma infinity. All right. So H and K coming from this expression. All right. So if you have, when you have y is equal to square root of x minus h plus k, that H and K give us information about the domain and the range when the parent function is a square root function. Now, example 2, let's consider a trig function. Okay. So example 2, f of x, we are going to consider, let's say, sine of x. All right. So the translated equation would then be y is equal to sine of x minus h plus a k. That's the same thing as saying f of x minus h, but f is sine. So we're using sine of x minus h plus k. Remember, this is going to affect the horizontal translation. This is going to affect the vertical translation. In your textbook, you've probably already seen this equation with other letters, something like this, y is equal to a sine of b x minus c plus d, all right? Where, this x minus c affects the same horizontal translation of that sine or cosine, the d affecting the vertical shift of sine or cosine, whichever function you're considering. And we are using h and k instead of that same c and d because we just are making use of a common y is equal to f of x minus h plus k, a common equation for the translation of any function. F can be square root function as we saw earlier, and now we're trying to explore for the sine function. It can be even an exponential function that if you would like to explore, but this is only the translation, okay? F of x minus h, this term inside is the domain. It affects the horizontal translation. K affects the range, the vertical translation. In the same way, this x minus h will translate the sine function horizontally, whereas this k will take care of a vertical shift, okay? Now, what we are more interested in finding out is that, is there any more information that the h and k, those values h and k will give us from the graph? Not just about the horizontal or the vertical shift, But is there some more information, like we saw the vertex, or we saw the minimum value of the domain and the range for that square root function? What other information can be gathered about this translated sine function from those values of h and k? Let's find out from the calculator, right? So here's our calculator. I've already inserted a new problem, and you can see the values of x go up to 360. So what we can do is that we can enter the parent sine function now, sine of x. And there's the parent sine function. And then we'll enter the translated trig function as sine of x minus 10. And outside the bracket, we're going to put 3, which means h is 10 and the value of k is 3. That means the translated function, the parent function was sine x, the blue function sine x, the translated function is going to go right by 10 units and up by 3 units. Okay, so probably we'll have to zoom out to see that. Yes, we can't see it. So I'm just going to go to menu and zoom, and let me just say, when I say zoom trig, what's going to happen. And there I can see, right? So that's sine of x minus 10 plus 3. And this is what we want to compare. Okay, so let me just adjust this quickly. So the blue graph is the parent function. The red graph is the translated function, as you can see that, x minus 10 plus 3. And what we're going to compare is, let's just see the maximum value. Okay, so let me just move this thing up here. The maximum value for the parent function. Okay, so analyze graph, and I'm going to say the blue graph. The maximum value occurs at x equals 90 degrees. And the maximum value of the function, the parent function, is 1. Okay, so at x equals 90 degrees, the parent function has a maximum value of 1. Let's do the same thing for the translated function. Let's see whether we can draw some conclusions about h and k. H is 10, remember, and k is 3. So analyze the maximum for the red graph, and there we go. And there we go. The maximum is occurring at 104. 100, the x coordinate being 100, and the y value being 4. That means the maximum value is 4. The maximum value is occurring at x is equal to 100 degrees. All right. Now, what's the relationship between h and k and this 90 and 1? As you can see, 90 plus 10 is 100. 90 plus that value of h is 100. All right. So the maximum value, the parent maximum value is occurring at x equals 90. Now, the translated function is having its maximum value as at 90 plus h. Whereas the maximum value of the parent function was 1. Now, the maximum value of the translated function is 1 plus 3, or 1 plus k in that sense. All right. So as you can see, h and k in this context, the context of the sine function, give other information, not about the coordinates of the vertex or the minimum value of the domain as we saw for the square root function. Here it is the maximum value of the parent function while it was occurring at 90. Now it's going to occur at 90 plus h. And the maximum value was 1. Now it's occurring at, the maximum value now is 1 plus k. Let's try for another transformation. Okay, so for the same one, let's just make this with a plus sign. So plus, let's say 30, and let's just make it minus 2, shall we? And let's see this one, where this is going. All right. Oh, it's the same thing down here. The same color I meant. Okay. So here we are. This is x plus 30, and these are not the maximum values. It's just the coordinate adjusted. So I'll have to remove this coordinate. Okay. So let's just go and delete that coordinate and run that maximum again. All right. So here we go. Let's run the maximum again, and let's see whether our analysis was correct. Okay. So this is the red graph. And now we can see that the maximum is occurring. This is translated. Okay. X plus 30. So h is negative 30 and k is negative 2. H is negative 30 and k is negative 2. So now watch. The maximum for the parent function was occurring at 90, whereas for the translated function, the h was negative 30. So the maximum for the translated function is occurring at 90 plus h. It's still plus h because the value of h is negative. Okay, h is negative 30. So 90 minus 30 gives you 60. In the same way, the maximum value of the parent function was 1. The maximum value of the translated function is going to be 1 plus k. All right, the value of k is negative 2. So 1 plus k is going to be 1 minus 2, giving you minus 1. So if we were to make a note of this observation, we'd say that if the maximum of the parent function was occurring at 90, 1, if the coordinates of the maximum were 90, 1, meaning at x equals 90 degrees, you've got the maximum value, and the maximum value of the function, parent function sine x, is 1, then for a translated sine function with h and k, all right, the maximum would occur at, so I'm just putting mt, meaning the translated, would occur at 9t plus h and 1 plus k. All right, and that can be said for any of the important points. That's why we were using word critical points, okay? That critical points can be a little confusing with the stationary points, but these are the important or the key points. That is what we wanted to highlight in this video. So what have we seen? We've seen this general equation for the translation for any function. The function can be a quadratic function, absolute value function, square root function, trig function. You can even explore for an exponential function. This general equation will give the translation for any function, x minus h, translating horizontally depending upon the sign of h being positive to the right, h being negative to the left. K is affecting the range, therefore it's a vertical shift, k being positive vertically up, k being negative vertically down. However, apart from the information about the horizontal and vertical translations of the parent functions, we saw that h and k also give us other information. In the case of quadratic and absolute value functions, we saw that the coordinates of the vertex, the translated vertex, are given by h and k. In the case of the square root function, we saw the minimum value of the domain and the minimum value of the range is also given by the h and k. And we also saw how h and k can be used to predict the next maximum or the next minimum for a sine function or a cosine function. I hope that this video was useful to you and helped solidify your understanding of translations of functions. In the next video, we're going to talk about dilations of functions. Don't miss that video.